Hey guys, this is Mr. Peterson, and right now we're looking at the transformations cheat sheet. One thing we need to remember with transformations is the first thing before we do anything to it. That's called the pre-image, which would be the original shape before you transform it at all. And we can call that A in this case, or B or C or whatever we want to call it. And then once we move it, that's called the image, and that's the new thing. So if we called the pre-image A, we would call the new image A prime. So there's four basic kinds of transformations that you need to know about. The first is a translation, and a translation is, you can think of it just like a slide. So to translate something is to slide each point the same distance in the same direction. When you do a reflection, you have done a flip over a line of symmetry or a line of reflection, and it creates a mirror image where it's flipped. A rotation is where you turn a figure clockwise or counterclockwise. And a dilation is where you enlarge or reduce a figure. And remember, that has to do with scale factor, which we'll look at here in a second. All right, so this next little block on the cheat sheet talks about all the different formulas you could think about that might perform these various actions. So, and again, you don't have these on the STAR math chart, so these are things you would need to memorize, especially the rotations and the reflections. So, translations that would go right and up, well, that would be, remember we would do arrow notation here, so you don't have to write this, but it's like, there's your arrow. So what that does is the X adds whatever you want to do, so N, and then it goes up by N as well, or B, or whatever it is that you're using as your number here. If you wanted to go left and then down, that would be X take away N, and then Y take away N. Again, if you want to draw the arrow in there, you can. Reflections over the x-axis, that's xy goes to x, negative y. A reflection over the y-axis, that's xy goes to negative x, comma y. A 90 degrees clockwise rotation, that would be xy goes to y, negative x. A 180 degrees clockwise rotation would be negative x, negative y. A rotation of 270 clockwise, well, that would be negative y times x. And then if you dilate with a scale factor of n, well, the way you do that with an ordered pair is you would do n times whatever your x is, comma, n times whatever your y is. You know, you might also want to write down here that these are clockwise rotations. So a 90 degree clockwise is the same as a 270 degree counterclockwise. A 180 is the same in both, but then a 270 clockwise would be the same as a 90 degree counterclockwise. With scale factor, it's the ratio of the new side length divided by the original side length. Or in terms of images, it would be the image side length, which is the new one, divided by the pre-image. If the scale factor is greater than 1, that creates an enlargement, so it enlarges. the scale factor is less than 1, it makes it smaller, which is it reduces it. All right, area and perimeter here. A scale factor of x will change the perimeter by a scale factor of x. Can't spell today. It's P-E-R-I-M-E-T-E-R. By a scale factor of x. And it'll change the area by scale factor squared, or x squared in this case. Remember also volume is affected by scale factor cubed. Okay, so in using real numbers here, a scale factor of 3 would make the perimeter 3 times larger, and it would make the area 3 squared, or 9 times larger. All right. Congruence means that you've got the same size and shape of a figure, or of figures. And if you look back up here at the top, the ones where they preserve the size and shape, that would be the translation, the reflection, and the rotation. So preserve means to keep, so that's the translation, reflection, and rotation. The orientation of a figure, that's the way that it kind of looks like right now. So that is the direction that a figure is facing on a coordinate plane. And in that case, a translation and a dilation would preserve the orientation. And if you look at our examples here, you know, the happy face is so you can't see that. Happy face is turned this way, and in a translation it's still the same way. The same thing with a dilation, still looking the same way. It did get bigger, but it's still looking the same way. Whereas with the reflection and the rotation, the way that it was oriented changed. All right, so there's that. You guys get to work on those new projects.